Hello and welcome back to CS165. We are on our fifth week, so we are discussing about database design using entity relationship diagrams. Nung pinakikinggan ko yung weekly check-up session recordings natin, na-realize ko na parang inaantok ako, masyado ako mabilis magsalita because minamadali ko yung 30 minutes na duration. And hindi masyadong maganda yung audio quality as well as yung kung paano ko siya pinaset. So, I am creating another video para mas ma-explain ko yung concepts ng mas maayos. So, let's start with our discussion. So here's an overview of our topic for week 5. First, we will discuss the different design phases, and then we will share the definition of the ER model, which is composed of entities and the relationship between entities. We will discuss that there are several types of mapping cardinalities between binary relationships, and then we will distinguish those types of objects or entities that are weak, so they are heavily dependent on so called strong entities. We will discuss also the most important part of this lecture, which is given an ER model, we will create or produce tables or schemas. And then lastly, for the extended ER features, we will discuss specialization and generalization. Here are the pointers for review as highlighted in this slide. Let's start with the different design phases. So in the academe, we actually have this process, formulation of the problem or actually understanding the problem. Next is identifying which algorithm to solve this problem. And then dun pala mag-start yung coding during the implementation. And then we assess either theoretically or empirically. So this design process is actually replicated when you go out to the industry. We have what we call the waterfall type of software development. So in the software development side, there's a step one. The step one is understanding the problem, which is equivalent to requirements gathering. And then second step is designing the solution given the requirements. And then step three is the actual coding or development. And then step four is the testing. If you have a machine problem, it's as simple as identifying the input and the output and then deciding ano ba yung pinakamagandang data structure to store this data. And if we go to the industry and we are solving a bigger problem already, we will need to identify the types of data that are needed by the application and the user, as well as how we will structure it. For a small application, sometimes the software developer is the database designer, but for a bigger project with a bigger solution, we need to assign a particular role to a specific person. So the database design is composed of three phases. The first phase is what we call the data characterization. First, we need to identify the needs of the application from the requirements gathering phase. And then we can list down all the types of data, all the information that we can get, and put it in a data inventory. And then we can also classify the types of data with respect to data type, data format. And then sometimes if we are creating a system that rides on top of another system or is integrated with another system, sometimes we need to do some migration. So we need to extract some information out of those existing systems and put it inside our database. So we need to plan those things and create a graphical structure of those data sets by producing what we call the entity relationship diagram. Given the entity relationship diagram in step 2, dun pa lang tayo makakapag-create ng table in SQL. So that's the logical design part where we specify the name of the table, the list of all the attributes per table, And then the second type of design is the physical design wherein we identify saan ilo-load yung database na yun. Will it be on the cloud? Will it be on-premise? What is the type of storage to be used? So, pwedeng SSD, pwede siyang naka-hard drive. And then, specific hardware specifications for the database servers. Okay. So, why do we need to design the database? We have the following motivations. The primary motivation is for us to avoid two major pitfalls. The first pitfall is data redundancy. So, if we allow data redundancy, then pwede tayong magkaroon ng tinatawag na database inconsistencies. So, we could have two queries with two different results and hindi natin alam kung alin dun yung mas tamang sagot. This is due to the duplication in the data attributes. The second pitfall is incompleteness of the data. If we have a portion of the data that is missing, it could produce inconclusive results. So imagine if you have a particular attribute and then you have 50% of the data, null yung content, and then you perform, let's say, the average or perform the computation of the sum, then the resulting computation will produce inconclusive results. To avoid two major pitfalls, we need to follow good database design principles that are incorporated in creating the actual entity relationship model and performing normalization. So we will discuss normalization on our week 6. So malito, more on week 6 dapat. Okay. So when we say entity relationship model, you're actually introducing two concepts. The first is the concept of an entity, and the second one is the concept of relationship. When we say entity, it's a thing, it's an object with specific characteristics or properties. So, a person is an entity. What else? A student is an entity. And then we have association between those objects or between those things. And that particular association is what we call relationship. The relationship between the different entities are summarized in what we call the entity relationship diagram. So this is a graphical representation of all the entities and all the relationships that we needed to model in the database. Let's start with entities. So again, entities are things or objects with attributes. To graphically represent entities, we use the rectangle with a name and a list of attributes. So for example, we have two entities here, the instructor and the student. For the instructor, we have characteristics or attributes called the ID, the name, and the salary. For the students, we have the ID, the name, and then the total credits. Inside the rectangle, we have some attributes that are underlined. So this set of attributes are the primary key attributes or the characteristics that uniquely identifies a particular object from the set of all objects. So, for example, your student ID is your unique identifier from all the set of students. Sometimes we have characteristics that can be decomposed further into component attributes. So, these particular characteristics or attributes are called composite attributes. For example, we have the name, and then the component attributes are the first name, middle name, and then last name. Sometimes, the component attributes can be further decomposed into subcomponent attributes. So, we have an example here for the address with the street, city, state, postal code. as the component attribute. However, for the street, it can be further subdivided into subcomponents. So we have the street number, street name, apartment number. We can graphically represent the composite attributes by writing the list of attributes with indents. So for example, yung first name, middle initial, and then last name, I may indent after the name attribute. And then for the address, you can see na yung may indents din yung streets and then yung street number. So sometimes we also have several properties that has more than one value. So an instructor can have multiple phone numbers. So to represent that this particular attribute is a set, we enclose it using curly braces. Another thing that we can represent as an attribute are derived values. So suppose we have information about the date of birth of the instructor. We know that we can compute the age of the instructor using the date of birth. So we can specify that the attribute age is a derived attribute from the date of birth. So medyo problematic if we will not have a derived attribute for age, because this is a duplication of the data. If whenever we update the, let's say, date of birth, if may correction and then hindi na update yung age, we can have inconsistencies in the database. Next is relationship. Remember that a relationship is an association among several entities or objects. So one example is the advisor relationship. The advisor relationship is between an instructor and a student. So we have, let's say, Peltier is the student of Einstein. So we can say that the advisor of Peltier with student ID 44553 is Einstein with instructor ID 22222. So formally, relationships are mathematical relations among n greater than equal to two entities, so at least dalawa, each taken from the different entity sets. So more formally, it could be a relationship between more than two. So we have n different objects, we are relating n different objects, and the particular relationship is a unique instance of all those possible relationship sets. So tuple containing e sub 1 up to e sub n is a relationship from the set of all relationship, which is called the relationship set. So we have the simplest possible example with n equal to 2. We are relating the student entity and the instructor entity, and this particular relationship is in the relationship set advisor. So graphically, we can see that the advisor relationship can connect an instructor and a student. So, for example, if we have these records, we can say that Creek, which is an instructor, is the advisor of Tanaka. Katz is the advisor of two students, Shankar and Zhang, and so on. So, since we can't enumerate all the possible advisor relationship, to simplify the representation, we just need to create an entity relationship diagram signifying that there is a relationship called advisor relating the instructor and the student. So the shape that we will use for the relationship is the diamond, and then there are lines connecting to both of the entities that are involved. In the modules, there are different types of connections. Sometimes it's an arrow, sometimes it's a double line. So it depends on the type of binary relationship between the two entities. Note that we can also have associated attributes in the relationship. So for example, we can add the attribute date in the relationship advisor, so we can include the date kung kailan nag-start na maging advisor ni student si instructor. Note that relationships need not to be distinct. So, pwedeng hindi two different entities yung nire-relate natin, but we are relating two unique objects inside one entity set. So, for example, we have the entity set course or the set of all courses. One course could be related to another course using some relationship. For example, we have the prereq relationship. So, one course is a prereq of the other. So, ang important lang for those types of relationship is we need to specify the role. So, one course is the course ID, the other course is the prereq ID, but both IDs are course ID inside the set of all courses. An example is the marriage, for example, relationship. So, one person is married to another person, and then for the roles, we can have the husband and the wife. So, if we have a binary relationship, one way to visualize binary relationships is by representing it using sets and connections between elements in both sets. So we have four different types of binary relationships, and it is illustrated on the right figure. We have the one-to-one, one-to-many, many-to-one, or many-to-many. So for the one-to-one, at most isang element lang yung pwedeng kumonek kay A sub i's. For one-to-many, pwedeng more than one element yung pwedeng kumonek kay A sub i's. Pero hindi pwedeng multiple A sub i's yung connected kay B sub I. For the many-to-one, baliktad lang si A and B. And then for the many-to-many, allowed ang multiple relationships between the two sets. Okay? So there are other additional constraints in the binary relationship. Sometimes we can specify that for all the elements in A or for all the elements in this entity set, dapat lahat may relationship dun sa kabila. And then, yung name for that is the total participation. And as a generalization for the mapping cardinalities, we can actually specify some cardinality constraints. So in this specification, we can say that we have a minimum of L connections and a maximum of H connections. So given a set, it's important to identify an element in the set. To uniquely identify an element in the set, we need a particular identifier. And yung identifier na yun is what we call the primary keys. And it differs depending on the type. So for entity sets, ito mas obvious, we can use the primary key since we are already familiar with primary keys from the previous weeks. However, for relationship sets, we can use the union of primary keys from related entities. So now we can have yung E sub 1 up to E sub n. So for example, to uniquely identify a particular relationship from the set of all relationship sets, we can use the pair instructor ID and the student ID. Or if we can include the date as part of the relationship attribute, then the primary key for that specific relationship is the instructor ID, student ID, and then i-augment natin yung attributes ng relationship. Note that the primary key identification for different binary relationship differs. So if it is a many-to-many relationship, then we need to get the primary key from each side. So if we have a one-to-many relationship, it is enough to use the primary key of the many side. If we have a many-to-one, we just need to use the key of the many side ulit. And if we have a one-to-one relationship, then we can use the primary key of either side. Since we are talking about uniquely identifying a particular object from the set of all objects, we are now ready to define weaker objects or weaker entity sets. So, yung particular example na to was used in the book, the two objects, course and section. So, if we have a course, to uniquely identify a course, actually you have the section ID, sometimes the name of the section, the SEM, the year, and then the course. To uniquely identify a course, it's enough to say the course ID, the course name, the title, and the credits. And these two objects have a relationship because a section is associated to a particular course. If we just list down all the attributes of each of the two different objects and we create a relationship between the two called the sec-course relationship, then we can have redundant information. Ano yung redundant information na yun? There's a relationship between them, so may arrow na, and then we can also have an attribute na course ID, tapos may course ID pa dun sa kabila. So, one way of removing redundant information such as this is to either remove the relationship sec course, but this is not desirable kasi graphically parang magkahiwalay pa rin si course and si section, tapos nakalagay na lang na may course ID siya doon sa loob ng table. So this is not desirable. Another thing that we can do is probably I can just remove the course ID and then just keep the sec course relationship. However, there's a problem with this. If this is just a regular entity, if we use the attributes of section, hindi enough yung union ng lahat ng attributes for the section is not enough to uniquely identify a section. Why? Because sometimes gumagamit tayo ng same section ID pero different courses and then they are offered sa same SEM and sa same year. So, what we need to do is to keep the relationship sec course, remove the course ID, and declare this as a special relationship wherein the other object is dependent dun sa another object. The other entity is a weaker entity because hindi kaya ng attributes niya to uniquely specify a particular section and dependent siya sa isa pang entity na strong entity because kaya ng course ID to specify uniquely yung particular course. So, this is graphically represented by using a double diamond and a double rectangle. Okay. So, given an ERD or an entity relationship diagram, our primary goal is to create a list of tables and their corresponding schema. So, how do we create schemas out of ERDs? Case-to-case basis. So, if we have a strong entity set, this particular entity can be directly translated to a table named course and with attributes equal to the listing below. Uh, However, if we have a weak entity set, meaning hindi enough yung list of all attributes niya to uniquely identify a particular section, then we have another way of creating a table out of it. And we can create a table out of it by, creating a section table, include all the attributes of the section. So, andyan si sec ID, SEM, and year. Plus, idagdag natin yung primary key ng entity kung saan siya dependent. So, yung part na to is what we do for weak entity sets. And then sometimes we have composite attributes. What we need to do is to flatten the list. So, just make sure that each of the leaf in the tree a separate attribute. So one method is to just remove the internal nodes of the parang hierarchical tree that was shown a while ago, or just create a name that uniquely identifies all of the leaf. So for the first name, we have name underscore first name underscore middle initial, and so on. So medyo hahaba lang yung attribute name natin if we will use that convention. The other convention is just list the leaf. And then, if we have a particular attribute with a close and open curly braces, so it's a set of phone numbers in this case, we need to create another schema. And this schema is the instructor phone. For the instructor phone, the attributes are the ID of the pinanggalingan na entity, and then we have the phone numbers, the individual phone numbers. So, it is possible to have one ID with multiple phone numbers. So, mauulit lang yung ID and then the phone number. ID 1, phone number 1, ID 1, phone number 2. How about for relationships? So, if we have a many-to-many relationship, we have another schema for it with the title or with the table name equal to the relationship name, and the content are the primary keys that uniquely identifies the relationship. So since this is a many-to-many relationship, then we need to get the primary key of the instructor and the primary key of the student. So iba naman yung case if we have a many-to-one and one-to-many relationship. If we have a many-to-one and one-to-many relationship that are total on the many side, it can be represented by adding an extra attribute to the many side containing the primary key of the one side. So in this case, we have a many-to-one relationship between instructor and the department. So yung relationship natin is the in-depth. We don't need to create another schema for this, but it is enough to add yung primary key ni department name doon sa many side. So, for the instructor, hindi lang enough na attribute si ID, name, and salary, but in order to reflect the relationship between instructor and department, we will append the department name in one of the attributes for instructor. So, mag-a-apply lang yan sa may mga total relationship. So, total sa instructor side. So, all instructors must belong to a department. So, another example is the student department relationship. So, this is a many to one, many students to one department. And then we have a total. So, all students must belong to a department. In this case, this is a many to one and then total on the many side. We don't need to create another table for the student department. We just need to append the department name inside the schema for the student. If we have a one-to-one relationship naman, so wag mo na natin tinignan yung figure sa baba. What we need to do is to choose one side as the many side. So, yung extra attribute natin can be added to either of the tables corresponding to the two entity sets. If the participation is partial on the many side, replacing a schema by an extra attribute in the schema corresponding to the many side could result in null values. So, may caveat lang na, okay, pwede ka talaga magkaroon ng null values because hindi naman lahat ng student ay may advisor. So, for some students, may content yung advisor attribute nila. However, for some students, wala silang advisor, so the content will be null. But that is valid. So this is our last topic. It's about extended ER model, and we will discuss about concepts like specialization and generalization. To model the data, we can have one image that describes yung relationship ng mga different entities that have some similarities. So for example, employee, student, instructor, and secretary are four different entities with different attributes, pero all of them have the name, street, and city. Another way of looking at this is classification of the different entity sets. However, for a particular class, you can have special attributes associated with it. So, if a particular person is a student, you can include information like the total credits. If the person is an employee, then you can also add the salary of the employee. And for the set of all employees, you can actually have instructors, and then another set that is secretary. For instructors, we have attributes like rank, but don't have a rank for secretary, so it's important to note the hours per week. There are two types of siblings: the siblings that are disjoint and siblings that are overlapping. For overlapping siblings, pwedeng yung person is an employee and a student as well. If the siblings are disjoint, hindi pwedeng both. So, yung overlapping entities natin are employee and the student. Kasi, if you're a student, pwede ka rin maging employee, like a student assistant. And then if you're an employee, you can also be a student. And to graphically represent the overlapping relationship between the employee and the student, we use the direct arrow key. If we have a disjoint relationship between the siblings, we can use this particular symbol. And in this particular example, kung instructor ka, you can't be a secretary and vice versa. So if we have information about the classification of different entities within an entity set, we can have the following two methods for creating the table. We have method 1, which is simply listing down the schema for the higher level entity, and then for the succeeding entities, we keep the ID of the parang root node. So we have the ID of the person and then just add the additional attributes for the specific entity. So for example, if we have a student, then you keep the ID of the person and then add the total credits at the end. And then for the employee, you keep the ID of the person and then add the salary. So you will have three tables with the following attributes. The drawback for method 1 is that if you wanted to get the name of the student, you need to go through uh, two tables. So first, you get the ID of the student, and then if you wanted to get the name, you go to the person table, and then given the ID, you can get the name, the state, city, and all. So for method 2 naman, we have to form the schema for each entity set with all local and inherited attributes. So start with the person with ID, name, street, city, and then for the succeeding entities, we will need to replicate the attributes. So for student, include all the attributes of the person. So we have ID, name, street, city, and then include the additional attribute for student. If you have an employee, you need to include all the attributes for the person and then add the salary. The drawback for method number 2 is you're storing redundant information for the three tables. So what we need to do here is to make sure that whenever we update the person name, the student and the employee name for the same ID ay dapat updated din to remove inconsistencies. If we have a total specialization, then walang magiging contents si person for method number 2. However, if we have a partial specialization, then we can have contents in the person table. Some of the additional concerns now before we end. We will post the exam on Monday. The main purpose of this is to synchronize the second part of the course para sabay-sabay tayo mag-start for week 8. Okay? And then, note that I'm uploading pointers for review. So, uploaded na rin yung pointers for review for week 3 for... Just make sure that you post your Q&A before our meeting so that we can have a discussion naman for the succeeding weekly checkup sessions. So, I guess that's it. Thank you for listening. Bye-bye.